All right, good morning, guys. I couldn't be here this morning. I'm unfortunately attending a funeral, and I will be back this afternoon, but we're starting a new unit today, and since I couldn't be here to go through the notes with you, I thought I'd do the second best thing. So I'm going to go through them fairly quickly in this video, and then I'll post this video on Moodle. I'll also post the notes on Moodle. And after you go through this video, you guys are going to get out your computers and you're going to work on the electromagnetic waves worksheet. I think it's going to be finished in class. I think you'll have plenty of time to get this done. So make sure you submit that and get a grade, and then next class we're going to have a quiz over this. All right, let's get started. So we're not going to do the daily concept check today, but I still want you guys to see the questions because you may see these on your quiz next class. Which of the following has the shortest wavelength? Red light, blue light, gamma rays, or X-rays? Number 2, orange light has a wavelength of 6 times 10 to the negative 7 meters. What is its frequency? The speed of light is 3 times 10 to the 8th meters per second. And you should already be able to answer that. Number 3, in a vacuum, the velocity of radio waves is blank the velocity of visible light waves. Is the velocity faster than, slower than, or the same as? And then number 4, how do humans utilize the electromagnetic spectrum? Is it through sterilization of medical equipment, communications, both A and B, or none of the above? So we're focusing right now on electromagnetic waves, and we just touched on these briefly when we came back this semester and started the waves unit. You guys should remember the difference between electromagnetic and mechanical waves. And the difference is, of course, that electromagnetic can travel through a vacuum and mechanical cannot travel through a vacuum. You don't have to know every detail about the electromagnetic wave. It's a fairly complex thing. But it does consist of 2 transverse waves. Remember, transverse meaning that the particles oscillate perpendicular to the direction of the energy movement. 2 transverse waves at right angles to one another. And so one is an electric field and the other is a magnetic field, hence the name electromagnetic wave. Now what you absolutely do need to know about electromagnetic waves is that they all travel at the speed of light. They all travel at the same speed. There are 7 different electromagnetic waves, and we'll talk about these 7. And they're very similar, but one similarity is that they travel at light speed, which is 3 times 10 to the 8th meters per second. Now you'll see right here that that's the speed of light in a vacuum. You guys remember what happens to light when it enters our atmosphere? It slows down, and it slows down even more in liquids, and as particles get more closely packed, light slows down even more. But the fastest light goes is in a vacuum, in empty space, and it's 3 times 10 to the 8th meters per second. Now this is our same equation that we had on the last test. Instead of velocity being wavelength times frequency, now we have C equals wavelength times frequency. And that's because now velocity is a constant, and we represent that constant with a lowercase c. We're going to typically talk about the speed of light in a vacuum when we get into the refraction of light. Of course, refraction meaning it's changing mediums and changing speeds. Then we'll start to talk about, when it enters another medium and slows down. Now, the way that we distinguish the 7 types of electromagnetic waves are based on their frequencies and wavelengths. So they're all traveling at the same speed, they're all electromagnetic waves, but some of them have a much higher frequency, therefore a much lower wavelength, or vice versa. Those waves that have a very large wavelength have a low frequency. Now this is the spectrum, and I think this is a pretty good representation of the wavelength of the different electromagnetic waves. And you're definitely going to be responsible for knowing these 7 types, and you'll see that they're listed across the top, and knowing the order. I won't specifically ask you what's the wavelength of infrared or what's the frequency of radio waves, but I may possibly ask you what type of wave has a wavelength larger than infrared, or a frequency smaller than X-rays. So you need to know that the order that they fall in, and you need to know what happens to the frequency as we go down this list, and what happens to the wavelength as we go down this list. So first, let me make sure I give you the 7 types, and you guys write these down. They're radio waves, microwaves, infrared, I-N-F-R-A-R-E-D, infrared. Then we get this tiny little sliver of the spectrum called visible light. Then ultraviolet, X-rays, and finally gamma rays. Now you'll see all these little pictures down here at the bottom, and those represent the relative length of the wavelength. And you'll see that there's just a huge variation. Radio waves have a wavelength as large as a football field. Yet when we get down into gamma rays, they have a wavelength the size of a nuclei, so very, very small. So the largest wavelength is going to be radio waves. Then wavelength goes down. As we go down the list, it gets smaller and smaller and smaller, and the smallest wavelength would be gamma rays. Now, if you remember from our last test, if velocity is constant, then frequency and wavelength are inverses. They're inversely related. So that means as I go up this list, or across this list, wavelength's getting smaller, but frequency is getting bigger. And so radio waves have a very low frequency. And then it gets higher and higher and higher, and gamma rays have a very, very large frequency. They can do the most damage. They're the most energetic waves, whereas radio waves are, they're going around this room all the time, and they're relatively safe. They're not gonna give you brain cancer like a gamma ray. But all of these are very useful. And so we're going to go through some of the uses for each. And please pay attention to what I say, because I'm going to give you a lot of uses, but you don't need to write down every single one. All right, so you got the spectrum. Now please don't write down all these numbers. I want you once again to know this list. So radio, micro, infrared, visible light, ultraviolet, X-rays, and gamma rays. And I want you to know that as we go down this list, wavelength's getting small. Wavelength's getting smaller, and frequency's getting bigger. So you do need to memorize that. You need to memorize the waves in order and what happens. What's the trend? Now, there are no firm boundaries. You'll see that they give 60 nanometers, the cutoff between ultraviolet and X-rays, but these are kind of ranges, more or less. There really are no firm boundaries between radio and microwave. So sometimes we'll talk about waves that are very similar to both. There'll be, a low frequency radio wave or a high frequency microwave. They could be somewhere in between. All right, so let's go through the different types of waves, and we'll restart my computer later. Radio waves are utilized by antennas of the appropriate size. We talked about radio waves can be as large as a football field. This is, by the way, an array of satellites out in New Mexico called the VLA, the Very Large Array. And they all work together to try to capture radio waves. But because radio waves are so big, they don't want to build one satellite, so they build several. What do you need to know about radio waves? Well, you need to know that they're useful for, of course, radio broadcasts, communication. They have the largest wavelength, smallest frequency. That's about it. Now you're going to see radio, or astronomy, that is. Radio astronomy, microwave astronomy. You're going to see astronomy listed on every one of these. And that's because stars give off, like our sun, gives off all 7 types of electromagnetic waves. And so astronomers, when they are studying stars, will look at the different waves that they emit. I'm going to go through this pretty quickly because I think it's interesting, but you don't have to know it. And that's the difference between AM and FM. AM is it's in kilohertz, by the way, is the frequency, and FM is in megahertz. So if you listen to 96.7, that would be 96.7 megahertz. But AM stands for amplitude modulation and FM stands for frequency modulation. You don't need to write that down. But it's just the way that they change the signal so that you can receive information from the radio station. Radio waves don't pass through our ionosphere, the charged layer of the upper atmosphere. And so even though you don't need to be in a direct line of sight for a radio tower, you just have to be close by because the radio signals hit the upper layer of the atmosphere and reflect back. And so as long as you are close to that transmitter, you'll receive the radio wave, unlike microwaves that pass right through the atmosphere. All right, microwaves. So what do you need to know about microwaves? Well, we utilize them in microwave ovens. In fact, the wavelength of a microwave oven is about the size of a water molecule. And so when it strikes a water molecule, it excites it and causes it to vibrate, and that's what causes your food to heat up. We use it for radar, for atomic and molecular research, for aircraft navigation. Oh, there's a microwave automatic door openers. So when you're going into the grocery store, there's probably a little transmitter that's sending a beam of microwaves through the threshold of the door. And so when you go into the grocery store, you break the beam of microwaves and the door opens. Microwave communication. So we use it quite a bit for communicating. Microwave less than lethal weaponry. So this is kind of an interesting weapon that the Air Force is creating. And here's like a handheld version, and here's a version that's mounted onto a tank. But it's basically a microwave transmitter. It sends out microwaves to anyone nearby. And it could, if you look at the little picture of the guy right here, he's going, ah, or Z, or I'm not sure what he's doing. But anyway, the water in his skin is probably heating up because he's being struck with microwaves right now. Very painful. So, but less than lethal. It's not going to kill you, but it's just going to cause the water in your skin to heat up. I'm going to skip this. It's really interesting, and if you take astronomy, you'll go into this in more detail. It's called the cosmic microwave background radiation. We're surrounded with this microwave background radiation. It's everywhere, and it is the closest evidence we have to support the Big Bang. All right, infrared. Infrared is, infra means below, and so infrared is below red. And red would be the largest wavelength, smallest frequency, color in the visible light spectrum. And so infrared is right below red. And infrared is what is felt as heat. So the heat we feel from the sun is the infrared that we're feeling. We use infrared a lot in like night vision photography. So here's a picture of a dog, and you'll see that the eyes and the mouth are really bright yellow, and that means they're very, very warm. Even the ears are kind of warm. But the hair is sort of purple, so it's a lot colder. Military uses infrared quite a bit for target acquisition, surveillance, homing, and tracking. But some non-military uses include short-ranged wireless communication, your remote controls, your Xbox remotes, spectroscopy, and weather forecasting. The how to see through clothing, if you search for this on YouTube, just put in how to see through clothing. There are some people that have taken cameras and turned them into infrared cameras, and they can use them to sort of see through clothes. It's a pretty silly video. I'm not going to go through it right now. All right, I'm going to stop here, and then I'll see you again in the second video.